this new unit will build on what we learned in our last unit on polynomials and polynomial division. And we're actually going to find in this lesson a shortcut for finding the remainder when we do a division. And why is that useful to us if we can find the remainder quicker? Well, one of the reasons that's useful is because it lets us know pretty quickly if something is going to be a factor or not without doing the division first. So remember function notation, this f of x, remember the zeros, long division, factoring, all of that is going to come in useful in this unit. So using what you already know, we're going to do some exploratory work. It says let's look at f of x equals x cubed plus 2x squared minus 3. And we want to find what happens when we take f of x and divide it by x minus 3 using long division. And then using function notation, find f of 3, meaning plug in 3 into this expression. So go ahead and pause your video now. And I do mean actually do it. Pause your video now and then use your long division skills from your last unit in order to evaluate this and then find f of 3. I'm serious. Pause. So there you've got it. We divided x cubed plus 2x squared. I had to add the 0x in because there were no x terms here. Minus 3 divided by x minus 3. Double check your work. You should get we should get a remainder of 42. And what do you notice when we plugged in f of 3? Well, we got 3 cubed plus 2 times 3 squared minus 3 is 27 plus 2 times 9 minus 3 is 27 plus 18 minus 3 is 42. Hang on a second. What we got here? We got a 42 here, and we got a remainder of 42 here. Coincidence? Don't think so. We're looking at f of 3, and this happens to be divided by x minus 3. Let's see if we can do a couple more and find a pattern. So let's look at g at x equals 2x squared plus 9. And we're going to divide that by x plus 2 using long division. And then you're going to find g of minus 2. And while you're at it, go ahead and do the h of x, which is 2x cubed plus x squared minus 41x plus 20, divided by x minus 4, and then find h of 4. And see if you notice a pattern. So pause your video, go ahead and do these divisions and evaluations, and then come back. All right, so what pattern do you notice? Well, when I'm dividing by x plus 2, I get a remainder of 17. When I evaluate g of negative 2, I get 17. When I divide it by x minus 4, I got a remainder of 0. When I evaluate it at 4, I got also 0. So you may be noticing plus 2, evaluate minus 2. Minus 4, evaluate 4, but I can get the remainder right away without having to do the whole silly long process of long division. And I can actually find the remainder pretty fast. Also, I can figure out, based on this last example, that if I get 0 when I plug in a number, I found a factor. And remember that when I plug in a number and I get 0, this would be called a 0 of the function. So 4 is a 0 of the function h at x, and x minus 4 is a factor of the function h of x. So if I find a factor, if I find a 0, 4, then x minus 4, change the sign, is going to be my factor. And that's going to end up being very useful to us. So let's summarize below what we found out. So we've got two things. We've got what we call the remainder theorem, and we've got what we call the factor theorem. So the factor theorem is really just a special case of the remainder theorem. It says if a function f of x is divided by x minus a, so in other words, x minus 4, 4 would be a, with a remainder of r, 0, then f of a, remember 4, a was 4, a was not negative 4 because I'm subtracting a, then f of a equals my remainder. And the factor theorem says that if I can evaluate f of a and get 0, then x minus a is a factor and a is 0. Well, a is a 0 by definition. F of a equals 0. That tells me a is 0. But that tells me x minus a is a factor. So those two things are going to end up being very important. Remember that because of this minus, we're always going to flip the sign when we evaluate. So x minus 4 gives me to evaluate at 4. And x plus 2, I evaluate at minus 2. That's going to be the one that gives me a 0. So if you need to pause your video for a second, write that down. That's your summary for what we've found so far. Then we're going to use it. So, given this polynomial k of x, we want to find k of -1, and then hopefully that will help us factor it completely. So, what we want to do is evaluate -1 in for each of my x values. So, k of -1 is going to be 8 times -1 cubed plus 30 times -1 squared plus 37 times -1 plus 15. We want to evaluate that. So 8 times -1 cubed is -8, plus 30 times -1 squared is still going to be plus 30, plus 37 times -1 is going to be minus 37, plus 15. And when I put those all together, what I find out is this is actually equal to 0. So what that tells me then is that -1 is a 0 of my polynomial k of x. Is a 0, meaning I found a factor. If I have one of my 0 is x equals -1, if I move it over to the other side, then I've got x plus 1 equals 0. That's where my factor comes from. That's why I'm going to flip the sign, because I know when I usually get to the end and I'm solving for x, I get x by itself, and now I'm going back the other direction. So my factor is going to be x plus 1. And I'm going to use that factor, x plus 1, to divide this whole big, long polynomial in order to be able to factor completely. So I've got 8x cubed plus 30x squared plus 37x plus 15. And I'm going to divide that by x plus 1. So I've got then 8x squared. 8x squared times x plus 1 gives me 8x cubed plus 8x squared. Subtract all of that. 8x cubed minus 8x cubed goes away. 30 minus 8 is 22x squared to the left. So I'm going to go plus 22x's. 22x times times x is 22x squared. Bring down my 37x. And 22x times 1 is plus 22x's. Subtract all those bad boys too. 37 minus 22 is going to be 15x. Bring the 15 down, plus 15, multiply that out, 15x plus 15, subtract that, and we do indeed get a remainder of 0, which is good. If we didn't, we'd have problems. So we have this remainder of 0 because x plus 1 is a factor, and because minus 1 is a 0 of my polynomial. Now, in order to factor completely, I need to also factor this 8x squared plus 22x plus 15. So if you remember how that works, 8 times 15, let's see, what does that give me? 8 times 15 is 120. So I need to find factors that multiply to 120 and add to 22. That's what I'm looking for. Factors that multiply to 120, add to 22. And I think what I'm going to get is 10 times 12. So I'm going to rewrite this middle factor, then move over here. 8x squared plus 10x plus 12x plus 15, and then do factoring by grouping. So this is going to have a common factor of 2x, and this is going to be 4x plus 5. And this has a common factor of 3, and this is going to leave me also with 4x plus 5. So I've got 2x plus 3, 4x plus 5, and my original factor was an x plus 1. We'll leave my polynomial fully factored. Boom! There I go. Got them all. Alright, next one. Create a polynomial that has zeros of 4, -3, and -1/2. So remember, if I have zeros, just like I showed you up there, I'm going to end up with x equals 4. Move that over to the other side. One of my factors is going to be x minus 4. If I have a 0 of x equals -3, move that to the other side. One of my factors is going to be x plus 3. And if I have x equals -1/2, multiply 2 to both sides, I've got 2x equals -1, and then move the 1 over. My last factor is going to be 2x plus 1 equal to 0. So I know that each of these are my zeros. That will give me each of my factors. So I'm going to recreate my polynomial based using these factors. So my polynomial is going to have an x minus 4. Oops, I'm going to leave myself a little more space than that, sorry. My polynomial is going to have an x minus 4, an x plus 3, and a 2x plus 1. That will be a polynomial that has these appropriate zeros, and you can see where you could plug each of those in to get it equal 0. Now the only thing that I have left to do is to expand that out so I get a polynomial that looks like this. I'm going to multiply these first two first to get me x squared plus 3x minus 4x is minus x minus 12. And then take that and multiply it by the 2x plus 1. So I'm going to get 2x squared minus 2x cubed minus 2x squared minus 24x plus x squared minus x minus 12. Collect your like terms. 2x cubed minus 2x squared plus x squared is going to leave me with a minus x squared. Minus 24x minus x is minus 25x. And minus 12. Boom! There it is. That's my polynomial that has the appropriate zeros. Now if you need to slow that down a bit, you can go back and take a look, try it on your own, pause the video, check your answer. It's up to you. You have the control. Alright, one more example before it's your turn. It says, find the value of k such that k cubed minus kx squared plus 2 divided by x minus 1 has a remainder of 8. Now, if you had to actually do this by long division, this would be a really complicated question. But because we know that if I have a remainder of 8, that means if I plug in the value that makes this 0, which would be 1, if I plug in 1 into this top part, it should equal 8. In other words, if this is f of x on top, then f of 1, because this is negative 1, equals 8. So if I plug in f of 1 is going to be 1 cubed, plug in 1 to each of these, minus, I don't know k, but this is 1 squared plus 2, that all has to equal 8. Then I just need to evaluate, collect my like terms, all that good stuff. So this is minus k plus 3 equals 8. Subtract 3 from both sides, minus k equals 5, or divide by negative 1, k equals negative 5, and you're done. So it's actually not as complicated as it sounds once you remember that all I have to do is evaluate by the number that makes this 0 on the bottom, or flip this sign, x minus a is 1, evaluate the 1, and then set it equal to my remainder. Now it's your turn. Show that x to the 51 minus 21x plus 20 is divisible by x minus 1. Now if you had to do this with long division, it would be stupid long, so don't. Make sure you're using your remainder theorem, your factor theorem. Pause your video, try it on your own, then come back and take a look. Alright, so here are your answers. The first one, all you have to do is evaluate f of 1, if I call this the function f, show that that's equal to 0, and therefore x minus 1 is a factor by the factor theorem. And the last one, find the value of w such that we're going to, again, flip this around to make this a negative 3, plug in negative 3 for x, solve for w, find out that w equals 0. That's all for today, folks. Good luck with your homework and your mastery quiz.